So in this video, I'm going to show you how we can use Google Earth Engine to derive various topological products like slope and aspect. So first of all, let me introduce you what is slope and aspect, because there might be people who are not familiar with slope and aspect in when working with the digital elevation models. So in the simplest sense, slope can be known as the steepness or the degree of incline of a surface. It can be computed as a maximum rate of change of elevation actually between the location and its surroundings. So having said that, aspect is, on the other hand, is the orientation of slope. It actually gives the direction of the slope, which means that aspect denotes the direction of the slope that we calculate previously. So in this image you can see on the left side the slope is denoted in degrees, which changes from 0 to 90. So in bright green color it denotes slope between 0 to 15, and when it slightly increases from 75 to 90, red color. So you can see in these areas the small bright red dots are available, which denotes the higher slope in the study area. So on the right hand side, you can see the aspect values. So in red color you can see the north, in northwest, like it's as I said before, it gives a direction of the slope value. So using the Google Earth Engine, we can easily calculate or compute the slope and aspect. So for that, we have to first get a digital elevation model, because without a digital elevation model, since we are working with elevation data, we cannot calculate like this slope and aspect. So another thing that I would like to highlight is that this calculating this slope and aspect is really important in hydrological applications. For an example, when we are working with flood modeling or landslide modeling, we need to have a slope as well as aspect data when conducting GIS analysis. So first of all, we have to import the image SRTM dataset. So we have to get the image ID from here, and then we can create a variable and import the dataset. So make sure to include this path in single quotes. So you don't have to actually, even though in JavaScript they have mentioned we need to have semicolons, you don't actually need it, but it is for good practice. I think it's better if you use the semicolons. So we can calculate the slope as with the built-in function for the slope calculation. And then we have to write a map function in order to visualize it. So let's run the program. So now you can clearly see the slope calculation, how it is denotes. So in white color you can see high slope area, high slope or the high slope area or high variation of slope. So in black color it denotes a low variation of slope, where it might in those areas there might be a high elevation, but in here when we calculate the slope, we can clearly identify which areas have the highest steepness. So there can be areas with very high elevation but lower steepness factor. And then we can create another variable for aspect and calculate the aspect with the inbuilt function. So we can write another map-add layer function, replace this argument with aspect. We can comment it out for the time being, and let's run it again. It might take some time depending on your performance. So by looking at this directly, you will not get a specific idea like the slope from here. However, when you are working with hydrological applications in later part of this lecture series, I will show you how this slope calculation or the aspect calculation is useful. So for an example, when we are working determining watershed areas, so demarcating drainage lines, these aspect slope line aspect both equally important for the analysis. So stay tuned for the next video.